Okay, so what we're going to do today is we're going to finish up on our vector math problems. Specifically, how do we preserve the precision of our measurements? We can't do that with the graphical method because if we have 4-place precision on our measurements but only 2-place precision on our protractors, we lose a lot of information. Okay, by the way, a little bit of an aside. Next person I see looking at their watch to do whatever messages, whatever, I get to take the watch. Okay? I'm just as guilty as everybody else. I get the buzz too, but I actually see people responding using the watches as well. And that's where we went over the line. Okay? All right. Back to the topic. Let's take a look at let's start off with a simple problem. Okay? Let's start off with a simple problem. Okay, example number 1. We're going to go ahead and use a standard mathematical definition as far as our axes. We're going to let the x-axis point to the right. We're going to let the y-axis point to the top of the page. By a parallel definition, we will let east point to the right and north to the top of the page. So that way we're all on the same direction. So if we say east would be positive x and north would be positive y. Okay? All good? Also, we're going to go ahead and define positive rotation as going from the x to the y-axis. Or another way of looking at it, counterclockwise. Given all that information, if your vector A is 15.5 meters long and is pointing 37.7 degrees from the x-axis, what are the lengths of its components? Go ahead and get started on that. What we are going to do is we're going to go through the method. This is going to be a recap for most of y'all. For those that know it, great. For those who don't know it, fantastic, you'll learn it. Here's what we got to do. It's all based on a simple theorem. The fundamental theorem of algebra states that, or rather fundamental theorem of arithmetic, states that any number can be written as a sum of 2 unique numbers. That is to say, the pair is unique. So if I choose a number like 10, I can write that there's an infinite number of pairs that sum up to 10. But each pair is unique. If I choose 4, then the other number must be 6. If I choose 15, the other number must be -5. Do you see where I'm going here? So when you choose the first one, the second one is of necessity. Well, we can do the same thing with vectors. Any vector can be expressed as the sum of 2 vectors. Okay? The trick is the vectors that we choose. Once we choose one vector, the other vector will come by necessity. So we're going to choose 2 vectors that are at right angles to each other. And these are going to be our components of the original vector. Okay? All good? Big surprise for y'all. You're sitting there going like, oh yeah, I'm just giving you the background of why you did what you're doing. So, in other words, I want you to make a right triangle out of your vector, where your vector is the hypotenuse. Okay? And then the skill that I need you to develop is finishing the triangle. That is to say, if I give you 2 pieces of information on a right triangle, you should be able to give me the other 3. You following along? We will be doing this until the end of the year. Not the end of the semester, the end of the year. Okay, so here's our problem. First, we're going to start off by drawing a coordinate axes. So there's x pointing to the right, there's y pointing to the left, all good. We're going to then draw vector A. We're going to place the tail of vector A onto the origin. So there it is right there. There's vector A, 15.5 meters to the northeast, or actually 15.5 meters, at an angle of 37.7 degrees. Okay, now I could try to scale this as best I could. I really could. I could probably draw 15.5 meters to scale, but I'm not going to be able to get the angle because my protractor is just too small. My protractor is only good to a degree. 1/10 of a degree if I've got a big enough protractor. So I'm going to lose precision with that. You see where I'm going here? Okay, so how do we do this? What we have to do is we have to finish the triangle. We draw the x component. That's going to be a line or a vector that is parallel to the x-axis. And then we're going to draw a y component, which is a line which is parallel to the y-axis at right angles to the x component. And there's our right triangle. At this point, I'd like to introduce you to a little friend of mine called trigonometry, because that's how we're going to solve the problems. We're going to solve the problems of what the x and y components are by using trig. Okay, so where am I going with this? All right, let's take a right triangle. And there's the hypotenuse. There's one side. There's the other side. We're going to go ahead and define this angle here as the angle theta. Okay? This angle here, we're going to call it angle phi. What's the relationship between phi and theta? Yes? Phi plus theta equals 90 degrees. Correct, because we know on a plane, in plane geometry, the sum of the angles in a triangle must be 180 degrees, and we know what one of those angles is going to be, namely the right angle. Okay, so phi and theta are complementary to each other. Let's say the angle of interest is theta. So this right here is our angle of interest. Then this side is called the hypotenuse. This side here, which makes up the angle theta, is the adjacent side, and this side becomes the opposite side. Okay. You guys should know your trig functions already, but if you don't, let me summarize it real quick. Our trig functions are the ratios of the sides to each other based upon the angle. For example, the sine of the angle theta is going to be defined as the ratio of the length of the opposite side to the hypotenuse. The cosine of the angle theta is the length of the adjacent side over the length of the hypotenuse. And the tangent is going to be the length of the opposite side over the length of the adjacent side. Okay? Now, you all remember that mnemonic that you got in high school, SOHCAHTOA, right? I use a slightly different mnemonic. I like sentences more than I like words. The sentence I use is some old hippie caught another hippie tripping on acid. Okay? That has the side benefit of being plausible. But in any case, you see how, but if you do that, you can write out the function with the ratio. Function, ratio, function, ratio. Okay? Now, let's say, for example, instead of this, let's say here's my vector AX. I'm sorry, that's not vector AX. That's my vector A. This is my x component, which I'm going to call AX. And this is my y component, which I'm going to call AY. Now notice I'm not calling these vectors because the subscript AX, AY will imply a direction to it. So AX is AX units in the x direction, and AY is AY units in the y direction. So far, so good? Okay. Now, the angle of interest, I'm going to go ahead and say this angle here, I'm going to call that angle alpha. Alpha is the angle of interest now. How do I find AX? Okay. In summary, it's not that hard. This is our problem-solving strategy all over again. Some of you are jumping right into it, and I understand it. Here's our problem-solving strategy. Number one, we've drawn the picture. Number two, we know our variables, our knowns and unknowns. In this case, we know the length of A, and we know the angle alpha. We want to know AX, and we want to know AY. What's the relationship? It's a right triangle, so we can use the trigonometric functions. Now we know the relationship. You see where I'm going here? First you recognize the situation, then you grab the tools from that situation. Okay, I want to find AX. Which function has the two knowns and the one unknown? The cosine does. So we're going to write that as the cosine of the angle alpha is equal to the length of AX divided by the length of A. So far, so good, right? Now, how do we solve this? Yes? Multiply both sides by a, because we want to get the, when I say solve it, that means I want the unknown by itself. So if we multiply both sides by a, we get a times the cosine of alpha is equal to ax. Then and only then do we put the numbers in. 15.5 meters times the cosine of 37.7 degrees gives us ax. And now we can do the button mashing. See where we're going here, guys? A little bit aside, those of you who have TI-30s, I have to remind you something very important. The function buttons, the trig functions, the exponential functions, etc., they will apply that function to whatever's in your display. So instead of going 15.5 times cosine 37.7, you're not going to end up getting the right answer. Because if you do that, it's going to find the cosine of 15.5. You need to reverse it around. You need to type in 37.7, find the cosine of that, and then multiply that by 15.5. Do you see where I'm going here, guys? Because again, the TI-30s, the basic TI-30s, they will do the calculation, they will do the function to whatever's in the display. Now, some of the more advanced TI-30s, like the TI-32X, where they have a line display on it, then it's going to do it in the proper order. Then you can just type it in. Okay? Just a reminder, these graphing calculators can't be used on the tests. Practice like you're going to perform. I would suggest you do your homework with the calculators you're going to take on the test. Okay? All right. So we do the same thing with AY, and it turns out the sine function for alpha gives us AY to AX, or excuse me, to A. That means that the expression becomes A times the sine of alpha gives us AY. I want you to be careful about one other thing. The other thing is this. It's too easy to think x component means I got to use cosine, y component means I got to use sine. Because what happens if instead of using alpha, I want you to use this angle theta right here? Then AX becomes what side? That's the opposite side, right? AX is now opposite of theta. It's adjacent to alpha. You following along? So draw the picture. I got to stress that. Draw the picture and you avoid that particular error. So let's move on. Now that we know how to do that, then all I have to do is draw the y component and then use the trigonometry functions to find the length, and we get 15.5 meters times the cosine of 37.7 degrees gives us the 12.3 meters. And the 15.5 meters times the sine of 37.7 degrees gives us 9.48 meters. And now you can see we actually, while we get down to the 10th of a meter, we get down to the 10th of a meter in the x direction, we can get down to the 100th of a meter in the y direction because we have three-place precision. We're preserving our precision here. Following along? Okay, cool, fantastic, terrific. Let's move on. Let's try another problem. Next problem is this. Let's add these two vectors together. Vector A is 15.3 meters long, pointing at positive 35.7 degrees. Vector B is 27.8 meters long, pointing negative 27.6 degrees. What's the magnitude and the direction relative to the x-axis of vector C, which is the sum of A plus B? Go ahead and get started on that, please. Okay, so my issue with you guys, with your guys' work, isn't really that you don't know what you're doing, as much as you're kind of making some big jumps. You're taking the big leaps. Use these whiteboards, use your paper to set up the problem so that the very last thing you do is put the numbers into your calculator. Okay? You don't take a look at these numbers, you don't take a look at these vectors and immediately grab a calculator and start mashing buttons. Down this way, one can get lost very easily, especially if I give you something like 5 vectors. Which one of your homework problems I do? Okay? So, how are we going to do this? Well, what we're going to do is we're going to draw a picture. And I'll put this in the PowerPoint slides. What I mean is this. Here's our origin. We know the first vector is going to be looking like this at about 30 degrees. So there's vector A. Now I'm going to take vector A and I'm going to add to it vector B, correct? And so that means I'm going to start vector B at this point. I'm going to rotate that direction and get the length. Now vector B is about twice as long as vector A. If you look at your numbers, you can see that's about twice as long. So I can draw vector B like this. So there's vector B. So what's A plus B is going to be this line right here. Here's A plus B. You see where we're going here now, guys? Now you see why I got it. Now you see why I said your lines don't look right? Your vectors don't look right? Okay, but here comes the problem. We've got to preserve our precision again. So to preserve the precision, we are going to use components. All right, here's how it works out. All right, first we can take those two vectors and we can break them up into 4 vectors. Because each vector is the sum of 2 other vectors, the component vectors. Yes? So A is going to be equal, let me go on this side. A is going to be equal to AX plus AY. And B is going to be equal to BX plus BY. Okay? Now all I need to do is take A plus B. Well, if I take A plus B and then I do the substitutions, then I end up getting AX plus AY plus BX plus BY. So as you can see, we start off with those 2 vectors. We're going to end up with 4 vectors. But we know the directions for each of those vectors. We know that the X vectors are going to be pointing to the left or right, and the Y vectors are going to be pointing up and down. So far, so good? Okay. Then let's just go ahead and reorder it. If I reorder this, then I get AX plus BX, and then I make my turn to do AY and BY. Okay? Cool. So what does it look like? It looks like this. First, we've got our coordinate axes. There, I'm going to draw A and B from the origin just as an illustration. So there's A and there's B. Next thing I need the components, don't I? Okay. So my components, well, the components for A is just a matter of making the right triangle for A. What about the components for B? Well, the same thing. Make the right triangle for B. But I want you to notice something very important. AX, which way is it pointing? AX, I'm sorry, not AX. AY, which way is it pointing? Up. Which way is BY pointing? You got to have those arrows there. See where I'm going here, guys? You've got to have those arrows. That's going to come into play on the next step, which is we're going to reorder everything. What we're going to do is we're going to go ahead and graphically add the components in the order. AX plus BX plus AY plus BY, so it looks like that. Do you see where we're going here, guys? We start off here. We go to AX at the end of AX. Then from there, we're going to add BX. Then we're going to add AY. Then we're going to add BY. That gives us to that point right there. Now all we have to do is draw the resultant of A plus B, and there's where we end up. Kind of cool, isn't it? Yes? Okay. Now, there's 2 other things we're going to deal with. If we take a look at A plus B, the red arrow, then doesn't that make a right triangle as well? What are the components of A plus B? Well, the components are no. AX plus BX gives me the X component, which is correct. The Y component is going to be AY plus BY. Now we look at this and we see, wait a minute, if we're adding two vectors, how can we get this vector that's smaller? Because these vectors have direction, don't we? Don't they? If I have a positive y vector, it's pointing up. What happens if I have a negative y vector? Pointing down. So I've got a positive value for ay, and I've got a negative value for by, and when I add those two together, I'm going to get a difference there. You see how that works out now, guys? Okay, and so we see that the sum of a plus b is going to give us this red vector, but we can also get that red vector by taking the sum of the x components for the x component and the sum of the y components for the y component. All good? So now we get to actually do the numbers. You see, drawing this picture out gives us the game plan. Now let's set up the equations. Okay, so here's what we're going to do. Step number one when we're doing vector equations, or when we're doing vector math, step number one, after you draw the picture, so it's really step number two, is to write the vector equation. The vector equation in this case is A plus B equals C. Okay, that's our vector equation. We're going to be running into vector equations all over the place. So far, so good? Now, we cannot solve this number. We cannot solve this problem right now because vectors have multiple dimensions oftentimes. So what we need to do next is to write the component equations. Okay. In other words, we need to take A and turn it into its components, AX and AY. We need to take B, turn it into its components, BX and BY. You with me here so far? Okay, let me take a little bit of an aside. I want to talk to you about how to write these component equations. Okay, so let me get back to my whiteboard program here. What happened here? Nope. Okay, so let me go back to my whiteboard program here, and I'll show you what I'm talking about. Sorry. Okay, so if I write out the equation A plus B equals C, then I know that the components of C are CX and CY. I need to find those. So I can do it three different ways. Number one, I could just go ahead and write AX plus BX equals CX, and AY plus BY equals CY. Okay, that works. You don't write them as a series of separate equations. You can do that. Another way that I've kind of found kind of helps out is make a table of it. In other words, here's the X column, here's the Y column. And this is A, vector A, this is vector B, and this is going to be vector C. So that means my components are AX, BX, or excuse me, I'm sorry, AX and AY, and BX and BY, and now all I got to do is just go down the columns to get CX and CY. So that's one way of keeping track of things. Okay? The third way is the way that's on the PowerPoint slides, and it's the way I do it. You do not have to do it yourself. Oh, and by the way, those of you who have done calculus-based trig, you may notice I'm avoiding IJK notation. Okay? If I do this, I don't need IJK notation. So it makes life a lot easier. Okay, the next way is column vectors. What that means is I'm going to take vector A and turn it into a column of AX, AY, and AZ. So in fact, I can actually make as many rows in my column as I have directions in my vector. So that makes it kind of handy there. So you see the position in the column determines whether it's X, Y, or Z. You with me here? Notice there is no line between AX and AY. There's no line going across. We're not separating them out by lines. If you do that, it makes it look like a division. It's just the position there. Then we're going to add B. So I'm going to go plus BX, BY, BZ. And that's going to equal vector C, which becomes CX, CY, CZ. And so you can see, all I need to do is go across the row like that to get the equations. You see where I'm going here, guys? Okay, so that's the way I do it. Column vector notation is what it's called. Okay, so back to my top. So now you see why it's set up that way. So there's AX, AY plus BX, BY equals CX, CY. The next thing we have to do, we're going to need to, once we get that, we can find what CX and CY are. We can find the length using the Pythagorean theorem. And we can find the direction by using the inverse tangent of the y component over the x component. All good? All right, so let's do this with this example number 2. A plus B equals C. So there's my vector component, my vector equation. I now write my component equation, AX, AY, BX, BY, CX, CY. The next thing I need is what are the expressions that give me those 4 components? If I let the angle that described A be alpha and the angle that described B be beta, then my expression becomes A cosine alpha, A sine alpha, B cosine beta, and B sine beta. You following along with me so far? Because again, we're making the assumption that if this is A, then this is the angle alpha, then this becomes AX, and this becomes AY. So now we have the expression there. Once we have the expression there, I can go ahead and put in the values. And so there's the values. 15.3 meters times the cosine of 35.7 degrees. 15.3 meters times the sine of 35.7 degrees. That's my A vector. For my B vector, notice, this is where the negative sign comes into play because it's rotating in the negative direction. So I'll just put in a negative sign for the angle. Okay? Now the next step could be go ahead, take out the calculator, and go ahead, go straight across. So it'd be 15.3 meters times the cosine of 35.7 degrees plus 27.8 meters times the cosine of negative 27.6 degrees. We could do that. I'm going to go ahead and just evaluate each one of those so it looks like that. So 12.42 meters and 8.928 meters for A, 24.64 meters and negative 12.88 meters for B. Okay? And now you see, if so AY points up, then BY has to point down. What's next? Do the math. Oh, one more detail. Why do I have 4 places when I have 3-place data going in? Any ideas? Go ahead. There we go. What he said is, so I don't do my rounding to the proper number of significant figures until the end of the problem, and the answer is yes. If I have intermediate calculations, I'm going to throw in a couple of additional digits in there so that my rounding errors occur in digits that I'm going to drop. Okay? All right, so we go ahead and do the addition, and we come up with 37.6 meters and negative 3.95 meters. So yay, there's X and Y. Now that I know that, then all I need to do is apply the Pythagorean theorem to get a distance of 37.8 meters. And then I use the inverse tangent in order to find the direction, which happens to be negative 6.08 degrees. And now you see I've got 3-place precision, and I'm able to preserve it all the way through. All good? Everything makes sense? Okay. What do you think you guys need? Practice. Yes, you guys are going to need practice. So that's the reason why I have homework for you, and that homework is going to be due on Friday. Now, a couple of asides. Number 1, I've got another practice problem for you, namely this one, example number 3. Vector A is 25 kilometers at 45 degrees south of east. B is 60 kilometers at 40 kilometers at 60 degrees north of east. We are running short of time, so we're not going to do that. What I'm going to do, though, is I'm going to take these PowerPoint slides, upload them into WebAssign, so you can work your way through, do the steps along the way, and should come up with the answer of 41 kilometers at an angle of 24 degrees north of east. So there's a little bit of a practice for you there. Okay. By the way, nice thing is on the video, since I've got that slide up, now you can see what the summary, the steps along the way. Okay? So again, the homework on this is due on Friday. So take advantage of the time both this afternoon and tomorrow afternoon to get them done. The test is going to cover up through this material. What we talk about on Friday will not be covered on the test. What we do in the lab period this week is not going to be covered on the test. But this material will be. Any questions from y'all? Yes?
So the test is going to cover like everything we've done in the lab plus everything in class, right?
Yes. Question was everything in the lab plus everything in the classroom? Yes. Lab 1 and 2 plus homework assignments 1 through 3. Those are all fair game. Anything else? All right, let's go ahead and call it a morning then, and I will see you guys when I see you next.